Exercise 2, question number 1. You push your physics reference book 1.5 meter. Okay, so 1.5 meter is the displacement S. Along a horizontal table with a horizontal force of 5 Newton. Okay, so this is the force F, 5 Newton. And then the frictional force is 1.6 Newton. So this is the frictional force. Calculate work done by the 5 Newton force, frictional force, weight and normal force. Okay, so we have to do this one by one. Okay, so maybe we can draw all the forces acting on this book. So the book is on the table. Okay, this is the book on the table. Okay, this is the table. So forces acting on this book are the weight, okay, vertically downward, and then the normal force 90 degree to the table, and then there is a horizontal force. Maybe the displacement is to the right. Okay, displacement to the right. Okay, displacement to the right. Okay, displacement to the right. Okay, so this is the maybe the location of the book after is displaced 1.5 meter. Okay, and then it has horizontal force 5 Newton and frictional force. Okay, frictional force is in the opposite direction of the motion. Okay, frictional force 1.6 Newton. Okay, so we have to find work done by the force. Okay, so first work done by force F. Okay, so work done by force F is force F dot displacement. So force is parallel to the displacement. So we can simply substitute force F, 5 Newton. And then the displacement is 1.6. Sorry, 1.5. Okay, 1.5. So work done by the force is 7.5 joule. Okay, 7.5 joule. And then work done by the frictional force. Okay, work done by the frictional force. Work done by friction. Okay, work done by friction. Okay, friction F. So work done by friction is friction dot displacement. Okay, friction is in the opposite direction of displacement, or maybe we can say that angle between the friction and the displacement is 180 degree. So it become F cos theta S. Okay, so substitute friction. Friction is 1.6 cos 180 degree time displacement 1.5. Okay, so work done by friction is negative 2.4 joule. So negative because work is done by the system. Okay, work is done by the book to overcome the frictional force. Okay, to overcome the frictional force to move to the right 1.5 meter. Okay, and then the third one is work done by the weight. Okay, work done by weight. Work done by weight W. Okay, So work done by weight is weight dot S. Okay, so angle between weight and the displacement is 90 degree. Okay, 90 degree. Okay, 90 degree here. So work cos theta dot S. Okay, so mg mg cos theta, mg cos 90 degree times displacement S. Cos 90 degree equals to 0. So work done by the weight is 0 joule. And then last is work done by the normal force. Okay, angle between the normal force and the displacement is also 90 degree. Okay, work done by normal force and okay, so work done by normal equals to normal dot S. So normal cos theta dot S, where normal and displacement is 90 degree. Okay, 90 degree. 90 degree. Okay, time displacement. So cos 90 degree equals to 0. So work done by normal is 0 joule. Okay. And then question B. Question B, the total work done on the book. Okay, we have two methods for B. Okay, for B, we have two methods. Work done total is work done by the force plus work done by friction plus work done by weight plus work done by normal. Okay, so work done by the force is 7.5 joule and work done by the friction is negative 2.4. Work done by the weight is 0 and work done by normal is 0. So work done total is equals 5.1 joule. Okay, we have two methods. Okay, so for work done total, work done total, we can determine work done total from force total, that's mean net force dot S. Okay, work done total equals to force total or net force dot S. Okay, so we can determine net force from all the forces acting on the book. So we have F and friction. So the net force is F minus friction. Okay, F minus friction, which is parallel to the displacement S. Okay, so F is the horizontal force is 5 and the frictional force is 1.6. Okay, times displacement is 1.5. So 5 minus 1.6 times 1.5 equals 5.1. Okay, 5.1 joule. It is the same. Okay, so when the question asks you work done total, whether you can use this method, you have to calculate one by one work done by each forces, and then you have to sum all the work done, or maybe you can just find the net force or force total. Okay, so force work done total equals to force total dot S, where force total is the net force. Okay, I think this is easier. Alright. 2. An object of mass 1.5 kg slide downward. Okay, slide downward on a smooth inclined plane A to C. That means there is no friction. Okay, no friction. Smooth plane means no friction. Okay, of length 25 meter. So this is the displacement. Displacement 25 meter. Determine the work done by the gravitational force in order to displace the object from A to C. Okay, work done by gravitational force actually is work done by the weight. Okay, work done by weight. Okay, work done by gravitational force is work done by weight. Okay, so work done by weight is equals to weight dot s. Okay, weight dot s. Alright, so this is the weight and this is the displacement. Okay, displacement s. So angle between displacement and the weight W is 90 minus 20 degree. 90 minus 20 degree equals to 70 degree. Okay. Okay. So it is mg cos 70 degree time displacement. Substitute mass 1.5. G is 9.81 cos 70 degree and then displacement is 25. So 1.5 times 9.81 times cos 70 times 25. So it is equals 125.82 joule. So it is positive because work is done on the system. Okay, because this object moved downward. Okay, this object moved downward, so gravity help the object move downward. Okay, slide downward. Okay, so it is positive. Okay, but if the object move upward, okay, if the object move upward, work done by the weight will be negative because work is done, okay, by the system, by the object to overcome the gravity to slide upward. Alright. Number 3, a box of mass 20 kg move up a rough plane. That means there is a frictional force, okay, which is inclined to the horizontal at 25 degree. So this is the angle of 25 degree. It is pulled by a horizontal force F of magnitude 250 Newton. Okay, so this is the force F, 250 Newton. Okay, the coefficient of kinetic friction between the box and the plane is 0.3. So this is the mu. Mu is 0.3. If the box travels 3.8 meter, so this is the displacement along the plane, determine work done on the box by the force F, and then work done by the gravitational force. Work done by gravitational force means work done by the weight. Work done by the force F, work done by the weight, and then work done by reaction force. Reaction force is the normal force, and then work done by the frictional force. And then B, total work done on the box. Okay, so for question AA, A part 1, we have to calculate work done on the box by force F. Okay, Work done by force F is force F dot S. But we have to identify whether force F is parallel to displacement. Okay, so displacement is here. Okay, the box move up the plane from here to here. So this is the displacement. Okay, displacement S. So F is not parallel to the displacement. So component of force which is parallel to displacement is this one. Okay, this one. Okay, so we have to resolve. Okay, maybe I can use black pen to resolve F. Okay, so this is the Fy, and then this is the Fx. Okay, so Fx is parallel to the displacement. Okay, maybe we can use this angle. So this angle is 25 degree, the same as this one. Okay, 25 degree. Okay, so it will become F cos theta times S. Okay, F is 250 cos 25 degree times displacement. Displacement is 3.8 meter. Okay, so 250 cos 25 degree times 3.8. Okay, so it is equals 860.99 joule. So this is positive. Okay, work done by force F is positive. That means work is done on the system. Okay, so this push force help the box move up the plane. Okay, this is push force. Okay, and then second one we have to calculate work done by gravitational force. Work done by gravitational force. Work done by gravitational force means work done by weight. Okay, work done by weight. Okay, work done by weight is weight dot S. Okay, but weight, okay, where's the weight? This one is the weight. Okay, I can label weight with blue color here. Okay, to tick. Alright, so this is the weight W. Okay, weight is not parallel to the displacement. So what is the angle between the weight and the displacement? Okay, this is the angle 25 plus 90 degree. 25 plus 90 degree. Okay, theta between weight and displacement is 25 plus 90. Okay, 25 plus 90 equals 115 degree. Okay, so this one become weight cos theta times displacement, where weight is mg. Okay, m is 20 kilogram, mass must be in unit kilogram, g is 9.81, cos 115 degree, and then displacement is 3.8. Okay, 3.8. So 20 times 9.81 times cos 115 times 3.8. So it is equals to negative 315.09 joule. So it is negative. Work done by weight is negative. Okay, because the box move up the plane, slide up the plane. So work is done on the system to overcome the gravity. Okay, work is done on the system to overcome the gravity to slide up the plane. Okay, And then the third one is work done by the normal. Okay, work done by the normal. Okay. The third one is work done by normal. Work done by reaction force is work done by normal. Okay, reaction force is normal force. Okay, work done by normal. Work done by normal is normal dot displacement. Okay, what is the angle between normal and displacement? Okay, this is normal. Okay, this is the normal force and this is the normal force and okay, normal force and this is the displacement. Displacement is this area, this one, displacement. So angle between normal and displacement is 90 degree. Okay, 90 degree. So it become normal cos theta times displacement, and cos theta is 90 degree. Okay, so cos 90 degree equals to 0. So work done by normal is 0 joule. Okay, work done by normal is 0 joule. And then work done by the frictional force F. Okay, the first one is work done by friction. Okay, work done by friction F. Okay, work done by friction is equals to friction dot S. Okay, so what is the value of friction? Okay, so this question give you the mu, the coefficient. Okay, but it don't give you the frictional force. So we have to find the value of friction by using formula. Friction equals to mu times normal. Okay, mu times normal. Alright. So we have to find the value of normal. Okay, normal is at y component. Okay, so from y component, okay, let us draw all free body diagram. So this is the weight vertically downward, and then this is the weight y, weight cos theta, and then this is weight x, weight sin theta, and then this is the frictional force, and then this is the normal force. Alright, and then this is the force F. Okay, so we have to resolve F to Fx and Fy. Okay, so normal force perpendicular to the inclined plane. Okay, this area. Okay, this area. Okay, normal is in this area. Okay, so we could apply net force Y equals to 0 for component Y. This box is in equilibrium because it doesn't move up and down. It doesn't move at Y component. It doesn't move like this. Okay, it doesn't move at Y component. Okay, it doesn't move up and down like this. Okay, it just move slide up. Okay, it just slide up the plane. Okay, this one. Okay, so for component Y, it is in equilibrium. So we have N, and then we have Fy downward, and then we have Wy downward as well. Okay, so it is negative, equals to 0. So let N be the subject. So N equals to Fy plus Wy. Okay, where Fy is F sin theta. Okay, and Wy is mg cos theta. Okay, so N equals to F. F is, what is the value of F? F is 250. 250 sine 25 degree plus mass 20 kilograms times G 9.81 time cos 25 degree. Okay, cos 25 degree. So normal force equals to 250 times sine 25 degree plus in bracket 20 times 9.81 times cos 25. So normal equals to 283.47. So we can determine friction. So friction equals to mu times normal. So mu is 0.3, is it? Mu is 0.3, yes. Okay. Mu is 0.3. Substitute mu 0.3 times normal that we calculated just now, 283.47. So frictional force equals 85.04 Newton. Okay. So we can substitute here. Okay. Friction dot S, we already calculate the frictional force F. Okay, but we have to identify first. When we want to use formula work done, we have to identify whether the force, okay, the force, so for here is the frictional force is parallel to displacement or not. So if it not parallel, so you have to find the component of force which is parallel to the displacement. So where is the frictional force? Okay, maybe I can use green color for frictional force. Okay, this is the friction. This is the frictional force, and then this is the displacement. So angle between displacement and frictional force is 180 degree. Okay, so we can substitute now. Okay, friction cos theta times displacement, okay, where friction is 85.04 cos 180 degree times displacement 3.8. Okay, cos 180 is equals to -1. Okay, 3.8. So it is equals to negative 323.16 joule. Okay, so work done by friction is negative because work is done on the system. Work is done on the box to overcome the friction, which is opposite direction of the displacement. Alright. So we already calculate work done by the force F, work done by the weight, work done by the normal force, and work done by frictional force. And then question B, the total work done. Okay, question B, the total work done. Okay, so for total work done, because we already calculate all the work done by each forces, we can use this one. Work done total equals to work done by the force F plus work done by the gravity. Okay, work done by the weight plus work done by the reaction force, the normal force, plus work done by the friction. Okay, work done by the force is 860.99. Work done by the gravity is negative 315.09. Work done by normal is 0 and work done by friction is negative 323.16. So work done total equals 222.74 joule. Okay, so we have another method for this one. Okay, work done total also can be calculated by using net force dot displacement. Okay, work done total equals to force total. Work done total equals to force total dot displacement. Okay, so we have to identify which force which is parallel to the displacement. So we have, okay, we can look at this one. Okay, displacement is up the plane, right? This is the displacement. So we the force which is parallel to displacement are, okay, Wx, friction, and Fx. So Fx in the same direction of S, friction opposite direction of S, and Wx of opposite direction of S. So the net force will become Fx, okay, Fx plus negative friction plus okay, Fx plus negative friction plus negative Wx plus negative Wx. This is the net force. Okay, this is the net force. Okay, this is a resultant force dot displacement. Okay, Fx is F cos theta. Okay, friction equals to mu n. Actually, we already calculate. Minus Wx. Wx is mg sin theta. Okay, this is the net force dot displacement. Okay, F is 250 cos 25 degree. Okay, minus friction, we already calculate here. Friction is 85.04. Okay, 85.04. 85.04. This is the friction. Minus mg sin theta. M is 20. Okay, G is 9.81. Sin 25 degree. Okay, so dot S. S is 3.8. Okay, 3.8 times 3.8. So 250, careful, 250 times cos 25 degree minus 85.04, then you get answer, and then you have to minus in bracket 20 times 9.81 times sine 25 degree, and then you get answer, and then you times 3.8. So it is equals 222.75 joule. Okay, it is the same. Okay, so we have two methods, and I think this one is easier. Okay, if there is no question A, okay, no question A, so question B is for the question asks you total work done, so it is easier to use this method. Work done total equals to force total dot displacement. Okay. So for question B, it asks you the total work done. How about if the question asks you calculate or determine the work done on the box? Work done on the box. It doesn't say by which forces. It doesn't say by which force. It just said you have to calculate work done on the box or whatever object. Okay, if the question asks you work done on the box, that means it is the work done total. Okay, it is the work done total. Okay, so if the question asks you work done on the box by which forces, so you just calculate work done by that force only. Okay, if it doesn't say by which force, that means the question asks you the total work done. Okay, alright.